Math 1033 is rational fractions. The reason you learn a lot of the factoring techniques that you already have is so that we can put them to place today. One of the techniques you've used several times for solving is cross multiplication, which is a shortcut to getting a common denominator. So on this one, I start off with the fraction equals a number, and one of the tricks we've learned, go ahead and put the number, let me get my pen acclimated, put the number over 1. That way they both look like fractions, and you can see that we're going to do the cross multiply. So this bar equals this bar. So we have 3x times x plus 1. All right, so following all the rules that we've learned, we need to simplify before we start doing any solving. So on this side, we have a 6. Over here, we have to distribute. So we have a 3x squared plus a 3x. Now, when I look at this, I see that it's a quadratic function. So when we have quadratics, we have to get them equal to 0 before we factor and solve. So I'm going to bring this 6 over. So I end up with 3x squared plus 3x minus 6 equals 0. Now, one of the things when we solve, we always look for a common denominator. So it looks like this guy has a common denominator. So the very first thing I'm going to do before I factor or do anything else with it is pull that common denominator out. It will usually make your life a lot easier. If it does not have a variable with it, it's not going to contribute to your solution, since you can divide both sides by that number, and 0 divided by 3 is still 0. All right, so at this point, we have this quadratic to factor. So we can go ahead and break it up, have an x and an x. Luckily, 2 is a prime number, so you only have one choice. We want the positive to be in the middle, so the larger number has to be positive. And then we're going to take both of these and create smaller little equations to solve for our factors. So this one says x is equal to -2, x equals 1. So before you say this is my final factors and get into my answers and jump up and down with joy, we need to look back at the original fraction. You'll notice there is a term on the bottom of x plus 1. We can't have a 0 on bottom. So to find our critical values or our things that limit our domain, just set that bottom equals 0 and solve. So x in this case cannot be -1. That was not one of the values that I got. So these are both good answers. So there's our first one using the cross multiply process. We'll do a couple more. This one is adding fractions, adding rational fractions. We all know, we've learned for years and years, if you're going to add fractions, you need a common denominator. The only trick with these is you need to make sure you have a common denominator that takes care of all the pieces that are involved in your fractions. So when I look at this, nice linear factor, but here's a quadratic. So I'm not quite sure what fractions or factors rather are hiding inside of this one. So you need to factor it. Okay. X squared minus 4, that's one of our special ones that we like, that difference of 2 squares. So x minus 2, x plus 2. So as I build my least common multiple or my common denominator, the first fraction says I need you to have an x minus 2. You say, great, I'm going to put an x minus 2. Second fraction says I really need an x plus 2. So I'm going to put that in. I look at the third fraction and I say, wait a minute, I've already got your x minus 2. I've already got your x plus 2. So this guy's happy. He's good to go. So we have our least common multiple. So because we have an equation, we're allowed to multiply both sides by the same thing. So we're going to multiply everybody over here by that least common multiple. And we're going to multiply this side. Now, as you do this, one thing I would suggest to write out, just take a minute, write it out, each term separately. And then multiply them, x minus 2, by that common denominator individually. It will help you see what's going to cancel. Let me go ahead and bring down the other side. We had 12 over. We're going to also multiply this side by that common denominator. All right, let's go through and see what cancels. This is my favorite part. So x minus 2 cancels with x minus 2. X plus 2 cancels with x plus 2. X minus 2 cancels. X plus 2 cancels. So let's see what we have left. Here we have a 3, and we have x plus 2. Plus, let's see what this one gives us. We have a 5 and an x minus 2 equals, over here, the whole bottom canceled with everything on top except for the 12. And so now I see a bunch of grouping symbols. So keeping in mind with all my order of operations, I go ahead and distribute. And now I know I need to add up like terms. So let's add up everything that's similar. And this is not a quadratic factor. There's no square or cube or anything. So I'm just trying to get the x by itself. So I add 4. I get 8x equals 16. Divide by 8. So if I have 8x over 8 equals 16 over 8. Divide the 8, x is equal to 2. Like I said, before I get all excited, I need to go back and see what my critical numbers were. So if this is my common denominator, I'm going to set both of those equal to 0. So x cannot be 2, and x cannot be negative 2. Boo. So when I look at my answer, I got 2. So 2 doesn't work. It's not in my domain. So this one has no solution. No number works. Even though we did all this lovely work right, it wasn't in our original domain, so we have to throw it away. All right, got another one I believe here. This one's maybe a little bit more straightforward because there's no adding and subtracting. But to be able to simplify a fraction, normally I cancel. But I can't cancel until I break this apart because of the addition and subtraction. So I need to factor both of them. And then I can see, is there anything that's the same and cancel it. So on top, I have a W and a W. Factors of 12 that have a difference of 1, be 3 and 4. I want the larger one to be positive since this is positive. Now, if there's anybody watching at home and have any questions, let me know. I have somebody who here can relay it. And then we can see if you have anything you'd understand that we did or if you have a specific question you want to look at. All right, let's look at the bottom. W and W. I have some choices on 16. I have 1 and 16, 2 and 8, 4 and 4. The ones that are going to add up to 8, or is that 4 and 4? And everybody's positive, so that makes my sign choice a little easier. And now I've got all the things factored, and I can look to see, is there anything that's the same from top to bottom? W plus 4 cancels with W plus 4. That's what's left over, and I'm not solving, so I don't have to worry about the domain on this one. I didn't find a value for x, it just said simplify. So factor and reduce what's the same. All right, one last one to look at, I believe. 2. Okay, we're going to do a multiplication. Normally when we multiply fractions, we all like that. We're pretty good at that. But in this case, I can't see what reduces until I do what? Until I factor everybody. So nothing to factor on the top here. But let's go ahead and factor the bottom. I've got a 2x and an x. Choices for 5 that somehow give me a 9. So I'm thinking 5 and 1. If I multiply the 5 times the 2, I'll get a 10 and a 1. I need the largest multiplied combination to give me a 9. So we have that little trick we talked about in a different workshop. Checking the nose and the smile. That'll help you figure out what signs if you're struggling with that. So when you take a 1 times an x, you get a 1x. 2x times a 5, you get a 10x. I want the larger one to be negative. So that means this has to be negative, and that has to be the plus. Well, that'll help me put my signs in place. Let's look at the second fraction. 25 minus x squared. Again, that's one of our favorites. That's that difference of 2 squares where they're the same, except for a plus and a minus. Then I have a 3. So now I need to start looking to see what's the same, what's different, what can I cancel, is there anything the same on top and bottom, and it doesn't matter which fraction it comes from. It could come from either one. So I see something that looks really, really similar. X minus 5 and 5 minus x. This is one of those tricks that you guys have learned in this class. If they look the same, I'll look at backwards. Have 5 minus x on top, x minus 5 on bottom. You notice they're exactly the same except for positive goes to negative, negative goes to positive. So if I factor a -1 out, it changes all the signs. And if I rewrite it, the x first, you'll notice all of a sudden it looks a lot more the same. They cancel, and all they leave behind is a -1. So I can cancel this guy with this guy. I'm left with a -1. 3 will cancel into 6 and leave me with a 2. So it looks like right now on top I have 2x in the first fraction, 2x plus 1 on the bottom of the first fraction, times -1 and a 5 plus x. And it looks like the whole bottom canceled. So this is where each teacher's a little different. Some will have you go ahead and distribute and multiply everything on top. Some will have you just leave it as is. So I'm going to go ahead and simplify a little bit. I'm going to take this -1, multiply it by my 2. So I would ask your teacher, do they want you to multiply these tops together or leave it simplified like this? All right. I believe I have one more sample. So flip to see. This time it's a division with fractions. It's really, really similar to multiplication. Many of you have heard the saying, keep, change, flip. That's how you change division into multiplication. So we're going to keep the first fraction. Change it to multiplication and flip the second. All right, now it becomes a multiplication problem, and we talked about a while ago. With multiplication problems, we'd like to cancel, but to do that, we need to make sure everybody's factored. So anything that's a quadratic, or even anything that might have a common term, we're going to pull all that apart, and then hopefully we'll have a bunch of stuff that cancels. We just did this one. We know that's the factor. And this one, let's see, looks like it factors x and x, factors of 8, They have a difference of 2. It's going to be 4 and 2. We need the larger one to be positive. 6x minus 2 has a common term of 2. Now, we're ready for the fun part. Anything the same from top to bottom of either fraction. So here's a 3x minus 1, 3x minus 1, so that leaves me a 1. Anything else the same? Anybody see anything the same? No, so nothing else actually cancels. So we're left with a lot of stuff in this case. So x plus 4, x minus 2 on top. Now this had a coefficient of 2, so I'm going to bring it to the front. And that's my final answer. So now you guys can see why the sections that you had before this on factoring are really, really important, because at this point, we're not going to spend a lot of time factoring. We're going to assume it's mostly kind of a review and maybe talk about tips, like I did with some of the signs and the nose and smile. But if you don't get it factored right, nothing cancels right. So if you have any questions, be sure and let us know. Come on into Learning Commons or log on to the virtual Learning Commons and ask the Smart Thinking tutors. We've got several different handouts in the virtual Commons that are all about factoring, all the way from pulling out a common term to breaking apart quadratics that have different patterns. So thanks for joining us, and hope to see you later. Bye.